Hello, everyone. We are here presenting our work, StyleMe, towards intelligent fashion generation with designer style. StyleMe is an intelligent aided fashion design system for automatically generating clothing sketches with designer style and supporting intelligent colorization. Our authors of this work are affiliated with Hunan University and SIGCHI Innovation. According to the suggestions by the designers interviewed, in the creative process of fashion design, the design elements involve sketch, color, pattern, and detail respectively. Hand-drawn sketch and sketch colorization are the most laborious but necessary steps for fashion designers to design exquisite clothes, let alone complete a large number of fashion design works. To the best of our knowledge, no prior research works have tackled the automatic generation of personalized sketches for clothing images, and style transfer from sketch to clothing image meanwhile. In order to complete these two functions, three challenges need to be specifically addressed: how to prepare the design manuscripts of fashion designers and a large number of clothing pictures, how to generate sketches with designer style in large quantities, how to quickly colorize the sketch and make the color combinations harmonious and diverse. To address these challenges, firstly, for algorithm, we propose an intelligent framework that can generate fashion sketches with designer style and generate a variety of fashion pictures with different styles. Secondly, for system, we implement an intelligent graphic design system, namely StyleMe, to support the interaction process of clothing sketch generation and sketch style transfer. Thirdly, for evaluation, we demonstrate results from three forms of evaluations: a user study, an experimental evaluation, and a semi-structured interview with experts. To make this design process more efficient for designers, we developed an intelligent design system named StyleMe for automatically generating the shape and silhouette of clothing sketches and style transfer from sketch to clothing image. As shown in the screen, we have also implemented an interactive user interface for users to select the input of the sketch generation model, then use the generated output line sketch from sketch generation model, along with the selected reference picture in gallery to obtain the final style transfer image output. In the system pipeline, our first step is data preparing and pre-processing. The data here include 200 hand-drawn clothing sketch pairs for model input, and 3,000 clothing images crawled from websites for design referring. Then we input these 200 clothing sketch pairs into sketch generation model. After training the sketch generation model, input a clothing image, and the model can generate a clothing sketch with the specified designer's style. Next, we select 119 clothing sketch to train the style transfer model. The style transfer model consists of two encoder modules. One extracts content features of the sketch independently and the other extracts the style features of the reference picture, to decouple the content features and style features of the generated image. Then StyleMe output the final clothing design image. To evaluate the performance of StyleMe, we conducted 3 experiments and user studies to evaluate the performance of the model and an expert interview with designers to collect subjective feedback. In 3 experiments, the performance of model components, the design time, the efficiency and effectiveness are evaluated respectively. In the expert interview, we conducted a semi-structured interview with 2 professional designers. We carried out the interview on 3 main topics: the quality of the clothing sketch, the usefulness of the technique, and the usability of the system. The experts were also asked to provide some comments on the performance of StyleMe. In the first experiment, performance of 2 model components in StyleMe, which are adaptive channel feature normalization module and channel attention module, are evaluated through sketch generation and style transfer comparison tasks and a follow-up user study. As shown in sketch generation results, compared to other ablation experiment objects, the sketch lines generated by StyleMe include many details, which is more consistent with the style of human fashion designers. In the second table, we use 2 quantitative metrics to evaluate the experimental performance of our model, which include fresh inception distance and learned perceptual image patch similarity. In the FID and LPIPS metrics, StyleMe also greatly leads other model variants and methods. Furthermore, a user study are conducted to verify the influence of generated sketches with different qualities on sketch style transfer. As shown in the result, the 81% of participants preferred the style transfer images generated by the model with ADA-LIN component, the 73% of participants preferred the images generated by the model with CAM component, And the 53% of participants preferred the images generated by the model with StyleMe but without CAM compared with 37% of participants preferred another. In conclusion, StyleMe components and CAM components have a great impact on the image of style transfer. We also conducted a user study on the completion time of sketch and colorization for human designers and StyleMe to evaluate the performance of StyleMe by comparing the efficiency of human designers with and without StyleMe. We invited 30 design students to participate in this experiment, including 12 males and 18 females, with a mean age of 23. All participants were asked to complete the design task with and without StyleMe. When participants drew the first fashion works, there was not much difference in the completion time of sketching and the completion time of coloring. As they continued to draw more fashion designs, the completion time dropped sharply for designers using StyleMe compared with the human designer. In summary, the experiment shows that StyleMe can help designers be more efficient when increasing the demand of fashion design work. To evaluate the professionalism of StyleMe, denote ρ as the probability of the cases that a design work is from a human designer. To evaluate the personalization of StyleMe, denote eta as the probability of the cases in which a pair of works are designed by the same designer. To evaluate the universality of StyleMe, we directly used participant scores on each generated image, where 1 means very poor and 5 means very good. In summary, the results show that StyleMe can generate clothing sketches with designer style comparable to human designers and generate high-quality clothing images with style transfer as good as human designers. If you are interested in our work, please check out our paper for more details. Thanks for your attention on this presentation, and we are delighted to answer if anyone has questions.